Hi, hello, welcome back to Max 20. In this video, I'm going to evaluate integrals using residue theorem. Okay. Residue theorem states that f of z is analytic in a closed curve C except at a finite number of singular points within C. Then integral over C f of z dz equal to 2 pi I into sum of the residues at singular points within C. That means we have a region and a curve, closed curve C, and f of z is analytic inside C. We have a region and a closed curve C, and f of z is analytic inside C except at a finite number of singular points. That means f of z is analytic inside C except at some finite number z1, z2, z3, etc. zn. Except at these finite numbers z1, z2, etc. zn, f of z is analytic inside C. Then integral of f of z dz is equal to 2 pi I into sum of residues at the singular points. That means if z1, z2, z3 are singular points of f of z inside C, note that these are singularity of f of z inside C, not outside C. These are singularities of f of z inside C, then 2 pi I into residue at z equal to z1 f of z plus residue of z equal to z2 f of z plus residue z equal to z3 f of z. That means integral of f of z is equal to 2 pi into sum of residues at these singular points within C. That is residue theorem. Now let's solve these questions. 5. Question number 5. Integral over C z square plus 4 divided by z minus 2 into z plus 3 dz, where C is the first one, circle mod z plus 1 equal to 2, and second one mod z minus 2 equal to 2. This is our first question. Mod z plus 1 equal to 2 means center minus 1 and radius 2. Center minus 1 and radius 2 means 0, 1 are included, then minus 2, minus 3 also in this region. So singularities of this function is z equal to 2 and minus 3. Clearly z equal to 2 is not inside the curve. Z equal to 2 is not inside the, but z equal to minus 3 is inside the curve. So we want to find residue at z equal to minus 3. This residue at z equal to minus 3 of f of z, which is equal to z equal to minus 3 is symbol pole of this function. So we know that residue at a symbol pole is limit to z tends to minus 3, z plus 3 into f of z. That is limit z tends to minus 3, z square plus 4 divided by z minus 2. Putting minus 3, then we get minus 3 square, 9 plus 4, 13 divided by minus 5. Minus 3 minus 2 is minus 5. So integral of z square plus 4 divided by z minus 2 into z plus 3 is equal to dz equal to 2 pi I into sum of residue. Only z equal to minus 3 is the only singularity inside C. So singularity, residue at this singularity is minus 13 by 5. So this is our answer, minus 26 pi I by 5. Question mod z minus 2 equal to 2. That is 2 centered, 2 radius circle. Circle with the center 2 and radius 2. That means 3, 4 are there. Also 1, 0. This is the circle. So, according to this function, z equal to 2 and minus 3 are singularity. So, z equal to 2 is inside C. Therefore, integral of z square plus 4 divided by z minus 2 into z plus 3 is equal to, by residue's theorem, this is equal to 2 pi I into sum of residue at a singularity. Residue at z equal to 2 f of z, only z equal to 2 is inside the circle. So 2 pi I into residue at z equal to 2 is z equal to symbol pole. That means limit z tends to 2, z minus 2 into f of z. This is equal to 2 pi I into limit z tends to 2, z square plus 4 divided by z plus 3. This 2 pi I into 2 square plus 4 is 4 plus 4 18, 8 and 2 plus 3 is 5. That is 16 pi I divided by 5. Now next question. Integral over C e raised to 2z dz divided by z plus 2, z plus 4, z plus 7. For the circle mod z equal to 3. This is our question. Z equal to minus 2, minus 4, minus 7 are singularity. And mod z equal to 3 means 0 center, 3 radius. That means 0, 1, 2, 3 and minus 1, minus 2, minus 3. So minus 2 is inside and all are outside the circle. So this is equal to, this integral is equal to, by residue theorem, 2 pi I into residue at the singularity inside, z equal to minus 2 f of z. That means 2 pi I into residue at z equal to minus 2. Z equal to minus 2 is symbol pole. So limit to z tends to minus 2. Z plus 2 into f of z. So 2 pi I into limit z tends to minus 2 e raised to 2z divided by z plus 4 into z plus 7. Now putting the limit, we get e raised to minus 4 divided by 4 minus 2 is 2 into 7 minus 2 is 5. 2 cancel. We get e raised to minus 4 pi I divided by 5. This is the answer of 6th question. Next question is integral of 4z square minus 4z plus 1 divided by z minus 2 into 4 plus z square with the mod z equal to 1. So clearly z equal to 2 and z square is minus 4 means z is equal to plus or minus 2i. Z square plus 4 is 0 when z is equal to plus or minus 2i. These are the singular points. 2 plus or minus 2i are singular points. And this is mod z equal to 1 means unit circle. 0, 1, minus 1. This is I and this is minus I. Now 2i minus 2i are not inside the circle. Also 2 is not inside the circle. So these singularities are outside the circle. So by Cauchy's theorem, we know that this function is given function analytic inside mod z equal to 1. Hence, integral of this function f of z dz is equal to 0. Question 3z square plus z plus 1 divided by z square minus 1 to z plus 3 with the mod z equal to 2. This is our question. Z square minus 1 is 0 when z square is 1. That is z is equal to plus or minus 1 and z is equal to minus 3. So this is z plus 1 into z minus 1 and z plus 3. So all are plus 1, minus 1, minus 3. All are simple poles. Simple poles. Now circle is given by mod z equal to 2. That means center 0, 1 is there, 2 is there, minus 1 and minus 2 is there. Minus 3 is not inside the circle, plus 1 and minus 1 are inside the circle. So integral of this function equal to 2 pi I into residue at z equal to 1 f of z plus residue at z equal to minus 1 f of z. 2 pi I into residue of z equal to 1 f of z. These are simple poles, so limit is z tends to 1, z minus 1 into f of z plus limit z tends to minus 1, z plus 1 into f of z. Z minus 1 is z plus 1. This is 2 pi I into limit z minus 1 into f of z. Limit z tends to 1, 3z square plus z plus 1 divided by z minus 1, or there is z plus 1 and z plus 3. Z minus 1 cancel. And limit z tends to minus 1, 3z square plus z plus 1 divided by z minus 1 into z plus 3. Z plus 1 cancel. Now putting the limit, we get 2 pi I into, substitute z equal to 1, get 3 plus 1 plus 1, that is 5, divided by 2 into 4 plus z equal to minus 1 means 3 minus 1 plus 1, that is 3, divided by minus 1 is minus 2 into 3 minus 1 is 2. This is equal to 2 pi I into 5 by 8 plus minus 3 by 4. So this is equal to 2 pi I into 5 by 8 and this is 6 by 8. So that is minus 1 by 8. That is minus pi I divided by 4 is the answer. Next, 7th question. First, integral of 2z plus 1 divided by 2z minus 1 all square dz, where c is the circle, unit circle, mod z equal to 1. So 2z minus 1 is in the denominator. 2z minus 1 equal to 0 when z is equal to 1 by 2. So z equal to 1 by 2 is the singular point of this function. And z equal to 1 by 2 is inside unit circle. So we can write it as 2z plus 1 dz divided by, take this 2 outside. Note that this is square. So 2 square outside, that means 4 outside. We get z minus 1 by 2 whole square. So z equal to 1 by 2 is a pole of order 2. Not single pole, this is a pole of order 2. So this is equal to 2 pi I into residue at z equal to 1 by 2 f of z. So in order to find residue at a pole of order n, we use the formula 1 by n minus 1 factorial. Here n is equal to 2. This is pole of order 2. So 2 minus 1, 1 factorial into limit z tends to 1 by 2 d n minus 1, that means d1 d by dz of z minus 1 by 2 into f of z. It is 2 pi I limit z tends to 1 by 2 d by dz of z minus 1 by 2 into f of z is 2z plus 1 divided by 4. sorry, z minus 1 by 2 all square into f of z. This is polar of order 2. All square into f of z is equal to 2z plus 1 divided by 4. Therefore, 2 pi I into limit z tends to 1 by 2 d by dz. Limit z tends to 1 by 2. Derivative of this function is 2. 4 is constant. 2 by 4. Derivative of z is 1. 1 by 4 is 0. So 2 by 4 is the derivative. That means 1 by 2. So we get this is equal to 2 pi I into 1 by 2. That means pi I is the answer. Now next question. Integral of z plus 4 divided by z square plus 2z plus y dz, where c is the circle, mod z plus 1 minus I equal to 2. This is circle with the center minus of 1 minus I and radius 2. So this is 0 when z square plus 2z plus 5 equal to 0 when we get complex roots. That means z is equal to, this is minus d plus or minus, is minus 2 plus or minus root of b square for minus 4 into ac. That means 4 into 5 20 divided by 2 is equal to minus 2 plus or minus. This is root minus 16. That is 4i. Root of minus 16. That means 4i divided by 2, that is minus 1 plus or minus 2i is the root. Minus 1 plus 2i and minus 1 minus 2i are roots of this function. These are our singular points. These two are our singular points, and in order to find these singularities inside the circle C or outside C, we need to consider the modulus. That means modulus of, first consider minus 1 plus 2i plus 1 plus I. What is modulus of this function? Minus 1 plus 1 cancel. 2i plus I is 3i. Modulus of 3i is 3 into modulus of I is 1. So this is 3, which is greater than 2. That means this is outside the circle. Next consider minus 1 minus 2i plus 1 plus I. This is minus 1 plus 1 cancel. Minus 2i plus I is minus I. And this is modulus of minus 1 is 1 and modulus of I also 1. This is less than 2. That means minus 1 minus 2i is inside C. This is the singularity inside C. Therefore, integral of z plus 4 divided by, this is z plus minus 1 minus 2i, z minus 1 minus 2i into z minus 1 plus 2i. This equation we can written as z minus this root minus 1 plus 2i and minus 1 minus 2i dz. This is equal to 2 pi I into residue inside is residue. It is z equal to minus 1 minus 2i f of z. And this is simple pole. So this is equal to limit z tends to minus 1 minus 2i, z minus 1 minus 2i into f of z. And this is equal to this is equal to 2 pi I. Sorry, this is 1 minus I. 1 minus I in the question. So this is 1 minus I. That means 2i minus I is I. So this is inside the circle. That means minus 1 plus 2i is inside the circle. Not this. This is 1 minus I. Therefore, we get minus 3i here. So this is 3 and greater than 2. So this is outside the circle and minus 1 plus 2i is inside the circle. So minus 1 plus 2i, sorry, this is my mistake, minus 1 plus 2i. So minus 1 plus 2i. So we get minus 1 plus 2i, this z minus minus 1 minus 2i. Z minus minus 1 plus 2i, numerator and denominator cancelled each other. So remaining z minus minus 1 minus 2i. So putting limit we get 2 pi I into minus 1 plus 2i plus 4 divided by minus 1 plus 2i minus minus, this is plus 1 plus 2i. So we get 2 pi I into, for minus 1 3 plus 2i divided by minus 1 plus 1 cancel. This is 2i plus 2i, 4i. So what we get, 2 pi I into, we can write it as 3 plus 4i by 2, or we can consider this 1 by I. 1 by I is minus I. So this is minus 3i and minus I into I is plus 2 divided 2i into minus I square is already minus 1 and this minus plus 1 into 2 is plus 2 divided by 4. That is 4 and 2 cancel, then we get pi I minus 3i plus 2 divided by 2. This is the answer. Next question, integral over c z square minus 2z divided by z plus 1 all square into z square plus 4 dz. C is the circle, mod z equal to 10. This is our question. So singularity as z plus 1 all z. Z is equal to minus 1 and z square plus 4 is 0 when z is equal to plus or minus 2i. So minus 1, 2i minus 2i are singularities inside this circle. This is mod z equal to 10 means 0 center and 10 radius. 10 radius. So these points are inside the circle. Minus 1 plus 2i and minus 2i are singularities inside the circle, and note that z equal to minus 1 is the pole of order 2 and these are symbol poles. So integral of z square minus 2z divided by z plus 1 all square into z square plus 4 is z plus 2i into z minus 2i dz. It is equal to 2 pi I into residue at z equal to minus 1 f of z plus residue at z equal to 2i f of z plus residue at z equal to minus 2i f of z. So which is residue at z equal to minus 1. We can calculate separately. Z equal to minus 1 is pole of order 2. So we can use the formula. Residue at z equal to minus 1 of f of z equal to 1 by 2 minus 1 factorial, 1 factorial, limit z tends to minus 1, d by dz, pole of order 2. That means d by dz, z plus 1 all square into f of z. So, limit z tends to minus 1, d by dz of z square minus 2z divided by z square plus 4 is denominator. Z plus 1 all square cancel. So limit z tends to minus 1, derivative of this function. That means this is u by v form, denominator into derivative of numerator. This 2z minus 2 minus numerator z square minus 2z into derivative of denominator is 2z divided by z square plus 4 whole square. Now substitute z equal to minus 1. This is 4 plus 1 5 into minus 2 minus 2 is minus 4 minus 1 square is 1. 2 into minus 1 is minus 1 and this minus plus 2. It's 1 plus 2. This is 3 into minus 2 divided by 4 plus 1 5 square is 25. So answer is minus 20 plus 6 minus 14 divided by 25. This is residue of z equal to residue of f of z at z equal to minus 1. Next residue at z equal to 2i. Residue at z equal to 2i f of z is equal to, this is symbol pole. That means limit z tends to 2i, z minus 2i into f of z. That is limit z tends to 2i, z minus 2i into f of z is z square minus 2z divided by z plus 1 whole square into z plus 2i. Putting z equal to 2i, 2i square, z square is 2i square. I square is minus 1, 2 square is 4, this is minus 4. Minus 2 into 2i, this is 4i. Divided by 2i plus 1 whole square. 2i plus 1 whole square and 2i plus 2i is 4i. So this is equal to minus 4 minus 4i divided by 2i plus 1 whole square. We can use a plus b whole square. This a square, 2i square is minus 4 plus 2ab, 4i plus 1 square into 4i. So this is, we can cancel this 4 with the numerator. It's minus 1 minus I divided by I into, this is minus 4 plus 1 is minus 3 plus 4i. Also 1 by I is minus I. So this is 1 by I is minus I. So minus 1 into minus I is I. And minus I into minus I is minus plus I square is minus 1. Minus 3 plus 4i in the denominator. Now we can conjugate this. This is minus 1 plus I and minus 3 plus 4i. We can conjugate this using minus 3 using conjugate multiplication. Minus 3 minus 4i divided by minus 3 minus 4i. Multiplying this minus 3i minus plus 3 minus 4i into I is plus 4 and this is plus 4i. We get 1 plus I divided by this is a plus b into a minus b is a square minus b square. This is 9 plus 16, 25. So this is residue at z equal to 2i. Now we want to find residue at z equal to minus 2i. Residue at z equal to minus 2i f of z equal to limit z equal to minus 2i also symbol pole. Limit z tends to minus 2i, z plus 2i into f of z. This is limit z tends to minus 2i, z square minus 2z divided by z plus 1 whole square into z minus 2i. Now putting the limit minus 2i square is minus 4 and minus 2 into 2 plus 4i divided by minus 2i plus 1 whole square into minus 2i minus 2i is minus 4i. We can cancel this with the numerator That is, we cancel minus 4. This is 1 minus I divided by I minus 2I plus 1 all square. Minus 2I square is minus 4 plus 2AB, that is minus 4I plus 1. So this is equal to 1 minus I divided by minus 4 plus 1 is 1 by I is minus I. You can use minus I into minus I. And minus 4 plus 1 is minus 3 minus 4I. So this is equal to minus I plus I square. This is minus 1 divided by minus 3 minus 4I. Multiply it with the minus 3 plus 4I divided by minus 3 plus 4I. Multiplying numerator, minus I into minus 3 is 3I plus 3 minus 4, I square is minus 1, so plus 4 and minus 4I divided by, this is A plus B into A minus B, 9 plus 16. So we get minus I plus 7 divided by 25. So the integral is 2 pi I into the sum of these residues. We get the integral of f of z dz equal to 2 pi I into those residue. First we get minus 14 by 25 plus 1 plus I by 25 and last we get minus I plus 7 by 25. So this is 2 pi I minus 14 all at 25, is 25 outside, minus 14 plus 1 minus 13 plus 7. I minus I cancel. This is minus 6. Minus 14 plus 1 plus 7. I minus I cancel. So this is minus 12 pi I divided by 25 is the value of this integral. If this solution is helpful to you, then please like, comment and share this video. Also, don't forget to subscribe to my channel. Thank you for watching.